Okay, so here we go. We are starting the notes packets for chapter 3. So if you're virtual, you should definitely get that out or get it on BB9. Okay? So we are starting just today. We are going to, the main emphasis for this chapter is solving quadratic equations. Last chapter, we also dealt with quadratic equations, but we graphed them. Okay, we really focused on the vertex form, being able to plot that vertex, and then doing our scale, our rate of change, right one, or up one, right one, up three, right one, and so forth. Now we're going to be working on solving. So going back to like 3x plus 10 equals 8, and finding what value of x it can be to be a solution. Today we're going to talk about 2 techniques. Overall, we're going to talk about 3, but for today, we're talking about factoring, which we already learned how to do, to go from standard form to factored form for the parabolas. And then the second way we're going to do is square rooting today. So, how did we factor a quadratic equation? If I had like x squared plus 4x plus 8, how did we factor that? Anybody remember? That's... Oh, wait, no, that was going from, you're thinking of the opposite. That was going from factored form to standard form, where you would do first, outside, inside, last. You need, yes, the X box, where you put A times C at the top, B at the bottom. And then we can use the box technique to pull out our greatest common factor of everything. That's the first way we're going to use. Good news is that this does work. It's pretty easy. You guys feel pretty comfortable, I think, with factoring, but unfortunately it doesn't work all the time because you can't factor every quadratic equation. So we can only do it if the original equation can be factored. It's factorable. First thing you have to make sure, though, is that it's in standard form. Ax squared plus bx plus c equals 0. It has to be equal to 0. If it isn't, we can't use this other idea of the zero product property. Because basically the zero product property says if you have 2 things multiplied together, you know that 2 things multiplied together is 0. One of those 2 things has to be 0, doesn't it? So if you know 10 times 0, that's going to be 0, right? Because anything times 0 wipes it out, and it's 0. That's the idea here. We get it in factored form. We have something times something equals 0. Then we know both of those have to be at least equal to 0 in order for it to be 0. Sometimes I just love how it works. Like never. Okay, give me a second, virtual people, because we lost connection. First we had it, and they lost it. Now they have it, and we lost it. So this is great. Love it. Okay. Fingers crossed. Do I have a code? That's a promise. Now it takes probably about, there we go, back in. Okay, got it. So we're going to factor, okay? 2 factor. Remember, we are definitely going to use the Xbox method, but we are also going to, you cannot forget to pull out the greatest common factor first. Okay, pull out the greatest common factor. If that doesn't work, then go right to making your X. Difference of squares, don't even worry about, that works for your X also, okay? So let's take a look at example A. Is there a greatest common factor between 2x squared, negative 11x, and plus 12? No. Okay, so greatest common factor is done, but always check that first. So then I'm going to go right to the X box. What number goes at the top of the X? A times C. So that would be 24. A times C, or 24. What goes at the bottom? So I'm looking for two numbers that when they multiply together, they get positive 24, but when I add them together, I get negative 11. In order for them to multiply together and get a positive, they have to be the same sign. There you go. Negative 8, oopsies, and negative 3. Now, into our box, then, the 4 quadrants. Remember, your 2x squared goes in the upper left-hand corner. 12 goes in the bottom right-hand corner. And then what goes in the other 2? Perfect. But you do have to include the x's. So negative 8x, and it doesn't matter which one goes where. And now you just look for your greatest common factor for the columns and the rows. So what's the greatest common factor between 2x squared and negative 3x? That's just x. What's the greatest common factor between negative 8x and 12? It is 4, but remember, keep the negative because that's the one that's closest to that. The negative 8x is closer to that spot, and so keep the negative. What's the greatest common factor between 2x squared and negative 8x? And then what's the greatest common factor between 3x and 12? Negative 3x and 12. So all of that's old. That's nothing new. So what I would do next then is, in one parentheses is what's on the left side of the box, and in the other parentheses is what's on the top. Only now, we know that that has to be equal to 0. So what that zero product property tells me then is either this thing that I'm multiplying together has to be equal to 0, for the whole product to be 0, or this has to be 0. One of those two things has to be 0 in order for the product to be 0. And now we just have these really easy equations that we can solve for x. So x minus 4 equals 0. What would I do to get x by itself? Add 4 to both sides. So I get x is equal to 4. Or 2x minus 3 equals 0 isn't quite as easy, but what would I do first? Add 3 to both sides. So 2x equals 3, and then I would divide both sides by 2. So x would be equal to 3 halves. Those are my two answers. And 95% of the time when you are solving quadratic equations, highest exponent is 2, you're going to get 2 answers. Tyler. Come on up here. Sorry, I know it seems like you're kind of out in the middle there, but at least then you can see the board. Okay, any questions with that? Those are your two answers. X equals 4 and x equals 3 halves. Okay, I'll try not to use that green very often. It's just I ran out of highlighters and colors. Okay, let's take a look at B. Is there a greatest common factor? Wrong. What's the greatest common factor? There isn't a number that's the greatest common factor. Nice. Holy crap. So now, what goes in parentheses after is what's left over. So what would I need to multiply x by to get x squared? What do I need to multiply x by to get negative 8x? This one is almost done for us already. We don't have to do the x box at all. So, because of the zero product property, either x has to be equal to 0 since it's already equal to 0. Or x minus 8 has to be equal to 0. So x equals 0 is already solved. It's already done. X minus 8, if I just add 8 to both sides, I get x equals 8. And there are my two solutions. Okay, let's take a look at C. This one. We're going to learn a different way we can solve this one in a couple minutes here. But for now, let's start by just factoring, because we can also use factoring. Is there a greatest common factor? No, we can't do that. So then I go right to the X box. What number goes at the top? Negative 100, because remember, this is my A, that's my C. My B is going to be 0, because there isn't that X term. If I wanted to, I could write plus 0x, but I don't want to. So now I need to find two numbers that multiply together to get negative 100, but add together to get 0. Zach? We got a lot of Zachs in here, don't we? Okay. Now I've got my X, so let's go to the box and see what numbers I can plug in there. What goes in the upper left? Good. What goes in the bottom right? Good. And then the other two are, there you go. So, greatest common factors. What is the greatest common factor between 4x squared and negative 10x? 2x, good. What's greatest common factor between 10x and negative 25? Not x, because negative 25 doesn't have an x, so it's just 5. 4x squared and 10x, or 2x. And then negative 10x and negative 25. Negative 5. So, we have 2x minus 5 in one parentheses, and 2x plus 5 in another parentheses. That equals 0. As soon as we have that factored, then, we know that either this parenthesis has to be equal to 0, or this parenthesis has to be equal to 0. And then we can just solve those two equations. If I'm solving the first one, that would become 2x equals 5. So x would be 5 halves. I'm going to leave it as a fraction. Or, if I solve the other one, this becomes x equals negative 5 halves. Those are your two answers. Okay, try D. Try D. Okay, that's because of our technology issues and running out of time. Almost all of you found the greatest common factor, which was perfect, of 3. Okay? Once you pull that out, you get x squared minus x minus 6. When you go to put the information of a times c and b in the x, you use that is in parentheses here. That's your a, that's your b, and that's your c value. The 3 doesn't disappear. That just comes down towards the end once we have it in factored form. Okay? So I'm looking for a times c to be -6, b to be -1. So the two numbers that work are -3 and 2. So into the box then, again, I am going back to that one that's in parentheses there, x squared, not 3x squared. -6, not -18. So as soon as you pull out that greatest common factor, it's kind of as if that's gone. I don't use that anymore. So I would have 3, and then in parentheses, x minus 3 and x plus 2. Now, technically, I am multiplying 3 things here. I am multiplying 3, this x minus 3, and x plus 2. One of those 3 things has to be 0 because of the zero product property. Can 3 ever be equal to 0? No. You either have 3 or you have 0. So that will never, ever, ever be a possibility. So our other possibilities then are going to have to come from x minus 3 being equal to 0. In order for that to be 0, x would have to be 3. Or x plus 2 has to be 0 for the whole thing to be 0. And that would be x is -2. So those would be your 2 solutions. Any questions on those? Okay, basically what we just did for all of those solving, when we get x equals a number of some sort, that means y is 0 because the whole thing is 0. So what we're doing is we are also finding the x-intercepts. It's kind of the same thing as factored form. So for this example down here, we would have 2 x-intercepts of 5/2, 0, and -5/2, 0. Those are the x-intercepts. That's what we're doing when we're solving. We're finding the x-intercepts, the solutions, the roots, all of those. We talked about that when we talked about the graphs. Any questions with factoring? Okay, factoring works some of the time. Okay, square rooting, which we're going to talk about next, also only works some of the time. Okay, square rooting, you got to be careful because this can only work when there is only an x squared term. Only. If you have ax squared plus bx plus c, that bx, you cannot use square rooting. So what we're going to do, first step, isolate the x squared part. That means if there's anything plus with the x squared, get rid of it. If there's anything times x squared, get rid of it. Basically, you're solving for x squared. And then to cancel out the squared, take the square root of both sides. Squared and square root cancel each other out. So if we take a look at if x squared is 9, this is a very big, easy quadratic equation. Notice how I already have this x squared by itself. Nothing else is with it on the left side. So if I want to cancel out that squared, what do I do to get rid of this exponent? Yep. Square and square root cancel each other out. So I am left with just x over here. Oops, I forgot to take the square root of the right side also, because otherwise it would be lopsided. And then what's the square root of 9? Yes and no. It's 3 times 3, which is 3 squared. I agree. But also, what, Ben? Because remember, we are looking for a number times itself. Let me erase this quick. We are looking for a number times itself to be equal to 9. Is 3 squared equal to 9? Yeah. Is -3 squared equal to 9? Yeah. So this is how you get your two solutions. You cannot forget your plus or minus. So you might want to highlight this because I guarantee at least 40% of the class forget plus or minus when you're square rooting. But remember, I told you that about 95% of the time you get two solutions. So that's how you get your two. One's the positive and one's the negative. Okay, memorize the square roots. These you should know. Okay, you should already. If you don't, start working on them. These are the square roots. Oops, I want the pen. What's the square root of 1? What's the square root of 4? Square root of 9? 16? 25? 36? 49? 64? 81? 10? 100? I gave you the answer, sorry. 121. These might be a little new to you, but most people are familiar with 121 and 144. Okay. The next one, you should have them memorized at least through 15 squared. Okay. The next one, it's that number that nobody wants to say ever. So it's easy to remember that. So 13. That's another way to remember, right? Not immature, but that's another way, Zach. I just usually go the route of immature because you guys are high schoolers. No problem. Okay, then 14 squared is the reverse numbers, 196. So they're the same 6 and 9, but it's just 96 then instead. And then 225, people have a tendency to remember that that's 15. Okay, so let's take a look at example B. I'm going to do that one first because I think B is a little bit easier and more traditional. So the first thing before anything is we want to get x squared by itself. So if I was solving this for just x squared equals blah, 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 what would I do first? Nope, that's always going to be your last step. How though? What do I do first? I would absolutely. You're using those reverse order of operations when it comes to solving. Add 31 to both sides. That's a little bit better, right? Because now at least just the x squared is with 4. 225 plus 31 is x squared by itself yet? Let's get rid of that 4, so let's divide both sides by it. Now, Sophie, now to get rid of this little itty bitty squared exponent, square root cancels out So what's my final answer? Have to say both. You can either write it like this. This is read plus or minus 8. Or you can separate it and say x is equal to 8 and x is equal to negative 8, however you prefer. But I will tell you that by the end of this chapter, you will know this is read as plus or minus 8. And then we have to think of that as a positive 8 or a negative 8, because we know that there are two solutions. Try example second C. This should be D, sorry. Hello, Maddie. Try that second example right underneath. 3x squared minus 7 equals 53. Go fast. What's up? What's up?
Oh.
Oh, you do that?
Yes, you are, Paige. Problem here, what everybody's losing it because why? When you go to isolate, we add 7. You get 60. Divide both sides by 3. You get 20. When you go to take the square root of both sides, oh no, 20 doesn't have a square root. Then you do the factor trees. So, 20, I heard 5 and 4. 5's a dead end. 4 is, there you go. So now when I'm rewriting this is going to be x is equal to, don't forget the plus or minus. So plus or minus the square root of 2 squared times 5. So we get plus or minus 2 times the square root of 5. Right? Because that's squared. 2 squared cancels out, so it's just 2. Any questions on that one? Okay, now let's take a look at A. What's different about A than B and D? This is in vertex form. Okay, and we can't isolate that x squared. Well, what we can do, we can isolate this squared. Let's get that by itself. Because if I get that by itself, I can take the square root and I'll show you what happens. So how do I get rid of that negative 2 out in front of the parentheses? Not distribute. I'm not going to distribute. I'm leaving that parentheses alone. I don't want to touch it. Divide both sides by negative 2. So we're left with x minus 3 in parentheses squared equals positive 36. And now, since I have this with the squared on it, it's all in parentheses, and the squared is acting on all of the parentheses. To cancel out the squared, I can take the square root. What I do to one side, I have to do to the other side. What will I have left over if I square root x minus 3 in parentheses squared? X minus 3. Those cancel. So we have x minus 3 equals what? No. Yes, I told you. Not whatever. Because remember, most of our answers are 2. Most of our equations are going to have 2 answers. So you just gave me 1. That might happen once in a while, but most of the time it's going to be 2. That plus or minus is how you're going to get both answers. Either, or hold on, before we do that, To get rid of now this minus 3, what would I do? Add 3 to both sides. We would have x is equal to, you usually see that plus 3 first, and then plus or minus 6. And now we're going to break it up into one's going to be the plus, one's going to be the minus. So either x is going to be equal to 3 plus 6, which is your 9 that you guys all said and you got right. Don't just put plus or minus 9, because look at what happens when we do the opposite. This is the plus symbol. Now I'm going to use the minus symbol. So x equals 3 minus 6. Not just 3. Negative 3. So that plus and that minus comes from that plus or minus that you have to include with the square root. All right. Let's take a look at C. Oh, I see just the squared, which is good. So I have to get that by itself. So to cancel out this 1/2, I am absolutely going to multiply both sides by 2. We're on page 3. So I have x plus 2 in parentheses squared is equal to 60. Now what would I do? Yep, I want to get rid of the squared that's acting on all of the parentheses. What's that sound, Sophie, for?
I didn't make that.
Oh, I thought you did. Is that Paige? What's the sound for? It doesn't have a nice square root, does it? But before I even go get started on my factor tree, I'm going to include plus or minus. Don't forget that. So, 60. 10 and 6. Neither of those are dead ends. 5 and 2, those are both dead ends. 6 is, okay. We have some here that I can simplify. 2 squared times 3 times 5. Yep, so 2x plus 2 is equal to plus or minus 2 times the square root of 15. Yes. And then how do I get just x by itself? Subtract 2 from both sides. So I get x is equal to negative 2 plus or minus 2 times the square root of 15. Here, don't even bother breaking it up. Leave that as your final answer, because the last time, for example, A, we could break it up into 2 parts because they were whole numbers. Now I still have that radical. I can't simplify it anymore, so I'm just going to leave it. Okay? And then just know that in the original format, if x is equal to 9, for example, and y is equal to negative 72, that's just a point on your parabola. It's like your t-table. Okay, so your homework tonight, sorry, is page 2 of your notes. Just page 2, just that one page. Okay, my expectation for you guys is that that is done tonight, ready to go for tomorrow, because tomorrow we're going on to the next thing and you'll have page 3 for homework. And I'll be checking both 2 and 3 on Thursday. Homework. Homework tonight is page 2. All of your homework will be most of the time, unless I say otherwise, your homework.
Okay.
If it records, I will let you know. If it doesn't,
Will it be on BB9?
hopefully. Yep, but otherwise you'll have to talk to somebody in class to get the notes and copy them, okay? You're welcome.